Hello, boys and girls. Today we're going to look at finding the inverse of a function. So before you leave this video, you should be able to find the inverse of a function algebraically and tabularly. So what is the inverse of a function? An inverse of a function is switching the input, let's use some math terms, the domain and the range of a function. In other words, we're going to switch the x and y values. If a function has an inverse, it must be 1-to-1. That is, for every x, there is one y, and for every y, there is only one x. Okay? So we have what we call inverse notation, and it looks like this. So to see that f to the negative 1 of x, that's what we call the inverse of f of x. So what we talked about before, a function being 1-to-1, a horizontal line test is used to determine if a function is 1-to-1. Okay, and the way it works is that we draw if a horizontal line only hits a graph in one place, then it is a 1-to-1 function. All right, so we're going to use the horizontal line test just to determine if these graphs are 1-to-1. This one didn't show up a little well, so it looks like this is the cubic function. And so what I mean, if I were to take a horizontal line, let's make our line yellow. And I would draw this, I can't see that. And I would draw a horizontal line. Notice how at the bottom it only touches once, it's passing. But then when we get right to here, it's no longer passing. This horizontal line hits the graph 3 times. So this cubic function is not 1-to-1, and therefore it doesn't have an inverse. So it has no inverse. But if we look at a linear function, we can see that if it's a linear function, it is 1-to-1. So all linear functions are 1-to-1. So this one is 1-to-1, has an inverse. This is a linear function. This next function, if you recall, is a rational function. And when we do a horizontal line, there's no place where it's hitting the graph twice. So this is a 1-to-1 function. It has an inverse. This is the absolute value, if you recall. And if we do this absolute value, it doesn't take long before we see that it fails the horizontal line test. So it has no inverse. This is an exponential function. And this exponential function, if we do a 1-to-1, if we were to do the horizontal line test, we see that this function is 1-to-1. So it has an inverse. And if we look at the parabola does not have an inverse because it is not 1-to-1. So yes, 1-to-1. And this one is no, 1-to-1. Okay? So the horizontal line helps us determine that. So now we're going to find the inverse tabularly. And you're going to find that this is pretty simple. We're going to exchange the domain values for the y values. We're going to exchange the y values for the x values. Easy peasy. So let's say we have this function, f of x, and we want to find the inverse. So remember, this is an ordered pair. This value can be written as an ordered pair, -4, 5, -2, 3, 0, -1, because this is x and this is y, so on and so forth. So this is the function f of x. What does its inverse look like? Well, its inverse, we would just exchange the x and the y values. So the inverse would be 5, -4 would be an ordered pair. 3, -2. -1, 0. -3, 2. -5, 4. Notice I'm just exchanging the x and the y value. So this would be the inverse of this function. Now we want to know, is the inverse a function itself? If you recall from Math 1, if x repeats, then it is not a function. And so if we look at this, we don't see any repeating x values in the inverse. None of the values repeat, so therefore the inverse of this function is a function. Okay, let's do another example. This is g of x. I'm not going to write the ordered pairs like I did before. I'm just going to write the inverse. So the inverse would be -2, -7, -7, -5, 5, -3, -7, -1, -4, 1, and -3, 3. That would be the inverse. All I did was interchanged x and y. So is the inverse a function? Where is there any place where my x repeats? Oops, sorry, wrong one. We have -2, -7, 5, -7. Okay, wait a minute, we got to stop there. Since -7 repeats, this is not, the inverse is not a function. So that means the original expression was not 1-to-1. The original function was not 1-to-1. Not a function because f of x was not 1-to-1. Okay? Alrighty, so you can stop the video and you can try to do the next one, and then you'll come back and see the answer. All right, boys and girls, welcome back. So I'm just going to show you the answers right quick. Alrighty, if you have any questions on that, please ask me tomorrow in class. All right, let's go to, now we're going to do it algebraically. Here's where the fun part comes in. So I'm going to give you some steps, and we're going to do a couple of problems. And I think after a couple of problems, you'll see that they're really not that bad. All right, so the first thing you want to do is graph the original function and ensure it is 1-to-1. If it's not 1-to-1, we have to restrict the domain. Now, I am not going to give you any that you will have to restrict the domain for. And if I do, I won't require you to do it. All right, so then we're going to change the notation f of x to y, and then we're going to exchange or switch the x and the y variables. Then we solve for the new y, and then we write the equation in function notation. All righty, let's get started. All right, so for problem number 1, 5x minus 1, if you recall, 5x minus 1 is a linear function. So because it's linear, I know it's 1-to-1, so I can skip steps 1 and 2, and I'm going to go right to step 3. So I'm going to change this to y is equal to 5x minus 1. And then I'm going to exchange my x and my y. So this becomes x is equal to 5y minus 1. My goal here is to get the y by itself. So I want this by itself. I always start by getting rid of what's not attached to the variable. And what's not attached to this variable is minus 1. So we're going to do the opposite operation to get rid of minus 1, which would be to add 1. So we get x plus 1 is equal to 5y. To get y by itself, we now have to get rid of 5. So since I'm multiplying 5 by y, to get rid of that 5, I have to do the opposite operation, which is divide. So I have y is equal to x plus 1 over 5. And then I'm going to change this y back into its inverse form. So I'm going to have the inverse form, the inverse of x is equal to x plus 1 over 5. Now, sometimes the multiple choice might get a little fancy, and it might go ahead and divide 5 into each of those. So x divided by 5 is 1/5 x. 1 divided by 5 is 1/5. So it could look like this, or it looks like that. Okay? Let's do problem number 2. Okay? So in problem number 2, we're going to do the same thing. It is a linear function. So I know that it's 1-to-1, and I'm going to start by doing my steps. I'm going to change f of x to y. And then I'm going to exchange my x and my y values. And now I'm trying to solve for y. And to do that, I start by getting rid of what is not attached to y, which would be the 7. So since I'm adding 7, I'm going to subtract 7. Remember on the other side that we cannot combine like terms because they're not like. So I have to leave it as x minus 7. Now, 1/3, we're multiplying by 1/3. So to get rid of this, we would have to divide by 1/3. If you recall from the last unit, dividing by a fraction is the same as multiplying by its reciprocal. So I'm going to have x minus 7, and I'm going to multiply by the reciprocal of 1/3, which is 3/1. So I could leave that like that, or I could write it as y is equal to 3x minus 21, or f inverse is equal to 3x minus 21. Okay, let's come down here, and I'm going to do problems 5 and 6, and then I'm going to leave you alone to do 3 and 4. Okay, problem 5, we have y is equal to 2/3 x minus 4. Exchanging, we get x is equal to 2/3 y minus 4. We're trying to get y by itself. Okay, so how do I get rid of this 4? I add 4 to both sides. Now, again, I'm going to divide by 2/3. But dividing by 2/3 is the same as multiplying times 3/2. So that becomes 3/2 times x plus 4. So that'll give me 3/2 x plus 6. Because 3/2 times 4, if you use your calculator, you'll see that that is 6. Okay. All right. This last one that I'm going to do is we're going to set it up the same way. This is still a linear function. So because it's a linear function, I am going to, it's 1-to-1, so I know I can take the inverse. So I'm going to change this to y is equal to 7x plus 5 over 4. X is equal to 7y plus 5 over 4. Now, how do I get rid of the 4? To get rid of the 4, I'm going to multiply the whole thing by 4. So this 4 and this 4 cancels, and I am left with 4x is equal to 7y plus 5. Now, I'm going to do what I did before. I'm going to get rid of the 5 because we're going to adding that. 4x and 5 are not like terms, so I get 4x minus 5 is equal to 7y. And then to get y by itself, I'm going to divide by 7. So y, come up here, y is equal to 4x minus 5 over 7. We could also write that as y is equal to 4/7 x minus 5/7. Okay, dokie? All right, if you would go ahead and pause the video and try problems 3 and 4, I'll come back and show you the answer. All right, welcome back. And the answer for number 3 is going to be y is equal to x plus 11 over negative 5. But probably the way that would be written would be a negative on the outside and then x plus 11 over 5. And for the second one, you're going to get x minus 1 over 3 is equal to the inverse of x. Okie dokie. All right, that is so much for solving linear inverse problems. Come back and I'll show you how to do quadratic and square root functions.